Alright, for this video we're going to use some spatial analyst tools to basically figure out how much of a certain land cover type is in a watershed. So we have our watershed and our land cover field. This happens to be the 2013 land cover data set from the University of Minnesota, and then our major watershed layer. So what we need to do first is kind of decide, which of these land cover types we want to identify first by watershed, because you have to do them individually. So under Spatial Analyst Tools, we're going to reclass, do a reclassify, and so we're going to take this land cover raster, and we're going to basically need to figure out what we're going to reclassify. So we can look at the attribute table, and let's say we want to know where the coniferous forests are. So that has a value of 105. And so basically for everything besides 105, we're going to assign no data as the value. And we'll leave that as 105. So what this is going to do is make a separate raster data set that is just selecting that value of 105, which is coniferous forests. Alright, so the reclassify is completed, and what it's showing is just the basically conifer forests. So now what we want to do is determine how many conifer forests are in each watershed. And so to do that, we go to Spatial Analyst Tools, Zonal Statistics as table. The reclass field that we just made goes in as input value raster, and our watershed is the feature zone data that we want, and we basically we'll sort it by watershed name is just fine. So we're gonna do an output table here. And you can pick which statistics you want to generate. We'll just do all of them for this example. Alright, so when that finishes, you'll get a table. And again, this is sorted by minor watersheds, or well, major watersheds in this case. Major watershed name is what we picked. And it gives you a number of different fields with that, including a count. It shows you, if you did have different values, it would show you which ones were used. In this case, it was all 105 that we were using. So the count is the number of grid cells. In this case, it's a 15 by 15 meter grid cell, and so 15 by 15 is 225. So if you take 225 by this count, that gives you the area then of 217,350. So that is in square meters. You need to know what your data set is in ahead of time in order to kind of figure that out. Otherwise, you can divide the area by the count to kind of get an idea of the grid cell size as well. So now that we have that, what we can do is go back to our major watershed layer, and we can do let's say we want to add a field right off the bat for the amount of pine land. So we'll do conifers. Now we need to join in that new table we made. We're going to join it based on the name, demo table. So it'll join the attributes from our table that we did using the zonal statistics command. It'll join that to the very end. As you see, all these different mathematical fields. We joined based on this common field, which was name. Some of them don't match just because one's a statewide layer, one's more just a regional watershed layer. So we'll do a field calculate on our conifer acres field, and what we want to do is use this area. That's the overall area, but it's in square meters, so we need to convert that to acres. So that's a simple way to do that, is just to go to your search engine and find that value. Zero 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 247105. So that takes this area field, which is in square meters, and brings it back down into acres. So now we have a count of acres for this particular, or for all these minor watersheds in our work area. And then we can make our maps accordingly based on that calculated field normalized against the overall area in acreage. And there we go, we can see where we have more conifers on the landscape.